Okay, a very good morning to our lecturer, Dr. Muhammad Noor bin Othman. Today, my group is going to present about precision in practice, avoiding miscommunication on technical drawings. So, I myself, Dinendra, will explain the first part, which is the type of miscommunications that can happen. So, generally, the first one is misreading dimensions, such as mixing the units, confusing limit, bilateral, and unilateral tolerances. This can cause a wrong unit or missing zero, which can make a part fail the inspection, changing its fit and causing assembly problems. Because of this, the product fails inspection, and even if the part looks fine, it's still actually not fine by dimension wise. Second, the geometric dimensioning and tolerancing and data mistakes. Because like you don't know how to control its position, its orientation, the size, and not setting the datums properly. Because of this, it can change the shape and also the location relative to the datum. So if you set the GDT and the datum wrongly, the part can be the right size but still be in the wrong position or orientation. And this can cause misalignment, binding, leaks, or vibration. So the picture here, you can see how the errors here happens for more clearer understanding. Third one here is surface finish confusion because we are mixing the RA and RZ such as the average finishing and the normal finishing. So we have and also workers can actually miss steps. Okay, for example, um, the surface might have a different kind of average thing, but then a certain part is only turned. So surface finish affects usually the friction and the sealing fatigue and wear. And because of this, even though the dimension is perfect, it can cause the wrong finish and early failure in the bearings. And lastly, the notes and revision error. So for example, if workers use the wrong type of revision, or if they're not up to date on the type of revision or notes given in a technical drawing, they can actually make the product in the wrong sequence or wrong format, and this can change the quality of the product. So now I'll let my other group member discuss.
How miscommunication happens. Miscommunication often starts in an unclear drawing layout. When the drawing has too many overlapping dimensions, small text, and missing detailed view, it becomes hard to read. Important information like datums and surface finishes can be missed. Because of this, workers may guess or detail skips. A clear layout with larger text and proper details view helps everyone understand the drawing correctly and avoid mistakes. Another cause is mixing different standards without explanation. Sometimes ISO and ASME symbols are used together, or special symbols are added without a legend. This can confuse people, especially if they are trained in a different system. When the symbols are not clear, people will guess. Using only one standard and adding a simple symbol legend make the drawing easier to understand. Broken information flow is also a big problem. Some important details on the drawing do not appear in the process sheets, CAM notes, or inspection plans. When this happens, the shop may follow an incomplete process. For example, a part may be turned but not ground, even if grinding is required. To avoid this, all information must be shared clearly from the drawing to every stage of production. CAM translation drift is another cause of miscommunication. Sometimes the adult CAM settings do not match the drawing requirements. Toolpath may look correct on the computer, but the final part may be out of tolerance. Programmers must always check that the CAM settings match the drawing to avoid hidden errors. Lastly, assumption during handoff create problems. Designers may think everything is obvious. Programmers may think mechanisms will adjust. Mechanists may think inspection will accept small errors. This assumption lead to bigger mistakes. A short discussion before starting the job helps everyone understand the same requirement and stay aligned.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm gonna talk about why miscommunication happens. Miscommunication happens when the message someone sends is not the same as the message the other person understands. This can occur for simple reasons. for the first one is training gaps. Sometimes miscommunication happen because people don't get enough practice with technical detail like GD and T, symbol or surface finish measurement. When that happen, they only check the size of part and forget about the geometry or finishing requirement. Other than that, human factor. Another cause is human factor when people are tired, rushing, or looking at complicated multi-sheet drawing full of symbol. They can easily skip notes or misunderstand tolerance. The third is culture and assumption. Culture also play a role. If the team always says we have always done it this way, or people are afraid to ask questions, old habit can override a new instruction. For the fourth, language and term. Language can cause confusion too. If notes are only in English or abbreviation are mixes, terms like basic dimension or profile tolerance can be misunderstood. So the fifth one or the final one is process complexity. Finally, the process itself is complex from CAD to CAM to machining to inspection. Each step has a different role. Even small difference can drift away from the original design intent. A simple checklist that connect all the steps can keep the process aligned and ensure. Thank you.
Hello, and a very good evening or night to anybody that's watching this. And I am speaker 4. I am going to speak about effects of miscommunication. So, there are lots of the effects of miscommunication, but I am just going to list out at least 4 to the audience. So, the first one is quality problems. So, what are the effects of quality problems? It can affect out of tolerance features, misalignments, interference, leaks, vibration, and faster wear. This is a common in rotating parts and press fits where alignment and finish are critical. And what are the outcomes? The outcome is parts might pass initial assembly but then fail in service, harming reliability and customers' trust. So when we are building a good company, we have to get the customers' trust. But if our quality has problems and the materials are not good, we will lose our customer trust and get bad feedback. So we move on to the next slide, or maybe the next the next point that I'm going to talk about is rework, scrap, and downtime. So the next one, which I said just now, the effects are the company needs extra machining, refixturing, reprogramming the stuff, and repeated inspections, wasted materials, and idle machines. So when our quality is downgraded, of course, the company needs to improve or step up their game into reprogramming and get doing better things in their aspects so that they can get better in their own courses or in their own side of view so that they can get the customer's trust. And what are the outcomes? Schedule slip and cost rise through over time and lose lost through output when the shop tries to recover. So when the shop tries to recover and the schedule slip and cost rise through overtime, it will make the company downgraded towards the audience or the customers that want to make a project or something with the company. So we move on to the next point, which is safety and compliance risk. So what are the effects of safety and compliance risk in this topic? So the effects is critical features fail standards and still reach customers. So what are the outcomes? The outcomes are hazards, warranty claims, recalls, and possible penalties. Strong communications help catch issues before delivery. So each company must make sure their safety is on top and their compliance risk is low so that their critical features will not fail. So we move on to the last one, the last what we say, the last topic, or maybe the last point in my topic. So the last one is team culture and impact. So When the team culture and impact is low between the staff and the higher ranks, the effect is trust will drops between engineering and production people, because when they have no trust between each other, the outcome is very bad. And the engineering team and the production people, they will have some misunderstandings and they will make very bad outcomes. So what are the outcomes? The outcomes are continuous improvement slows, and the shop avoids better methods, even when those methods could prevent errors. What are shops? Shops are basically, or in this case, is customers. So yes, we will move on to the next speaker, and the next speaker is Harith bin Muhammad Aizam, and move on. Thank you.
Hello, right now I'm going to give you guys a solution step by step, and also suggesting you tips and tricks on how to communicate better in the future. Alright, there's a 5-step and tips and tricks. The first one is standards and drawing rules. Choose ISO and ASME and stick to it. Use a style guide, declare units clearly, include a symbol legend, and place feature control frames near the feature they control. The benefit is consistency removes guessing and speed up correct reading across shifts and team. It also makes training and audit simpler because everyone knows the rules. The second one is training and metrology practice. You guys run a short regular session on GD&T and datum setups. Teach the difference between RA and RZ on how to measure surface roughness. Gives a hands-on time with roughness, gauges, and basic coordinate measuring machine workflows. The advantage is team can read and measure what they can specify, design intent become practical, and error drops. The third one is communication routines. Do a pre-production drawing walkthrough with the whole team. Use the red line reviews and ask verified checkpoints for critical features, and require a sign-off before cutting metal. The benefit is these habits catch misunderstandings early when fixes are cheap and fast. The fourth one is clear layouts and visuals. Add detail and section views for complex areas. Use readable fonts, white space, and clear grouping of notes. Mark datum clearly and consistently. The benefit is a cleaner drawing reduces mental load, make a call-out visible, and help operators, inspectors work with confidence even under time pressures. The last one is digital aids and revision control. Use annotated PDFs and product and manufacturing information PMI in 3D CAD, so you can travel from design to CAM to inspection without losing meaning. Check CAM settings against the drawing tolerance and GD&T before running. Control document tightly so only the latest version reaches the flow. The advantage is everyone works from the same current specification. Design intent carries through and version related error drop. Final message: if drawing speaks a common language, manufacturing becomes precise, efficient, and reliable. This is how you protect performance, people, and trust on every job. Bye.